Today let's try to solve another Leetcode problem, 898, Bitwise ORs of Subarrays. So we are given an array. We want to calculate the distinct of bitwise OR subarrays. For example, let's use the second example. We have 1, 1, 2, so all the subarrays will be continuous. So in total, there will be 1, 2, 3, 4, 5, 6 subarrays, and all the unique will be 1, 2, and 3. So we want to calculate the number of unique values, and the length of the array is 5 times 10 to the power of 4. It means we cannot solve it by n cubic or n square. So we're gonna use the bit dp to solve the problem in n log n. Basically, it is 32 times this n. N is 5 times 10 to the power of 4. Let me first explain it in the whiteboard. After that, I will go to the code editor to finish the coding. So for this problem, we are given a random array. So let's prepare a random array inside. It can be any numbers inside this random array. So the maximum length can be 5 times 10 to the power of 4. So inside of this array, we want to calculate the bitwise OR of all unique values. So yeah, for the brute force, we're gonna think about how can we solve it by using the brute force. Yeah, by using the brute force, but we will optimize the brute force. First, index 0, and then, so for the index 0, we are sure this value will be inside the set, no matter which this value is. For example, this value can be 1 or 0. Yeah, for example, this value is 1. So we're gonna put this 1 inside the result set. Yeah, so this is one result. So for the next value, so this is the I index, when this I goes to 1. So for this number, how many combinations with the previous ones? So for the previous ones, we will put all the previous ones inside a set. So we're gonna check this value with the set. For example, this value is 2. So inside the set, it is a 1. So 2 or 1, so the result will be 3. Yeah. So currently, 2 and 1 have a result of 3, but we need also to plus this value 2. So this plus 3 plus 2. So here plus, I mean the bitwise OR operation. So 3 or 2 inside the result. So here, for this result, it can be 3 and 2. But what about the final result? So the final result will also include this one. This one is calculated before. So the final result will be 1, 2, and 3. Yeah. But how should we prepare this kind of calculation? Basically, we're gonna prepare a DP array. So inside the DP array, for the DPI, is all the value calculated at index I. For example, the DPI. So for this DPI is all the result before and also include this index I. So when it comes to DPI plus 1, it is always dependent on the value calculated before, because the DPI, here I will use DPI, yeah, calculated, but actually this will be DPI minus 1 for easy calculation, and finally here will be DPI. So the DPI will always be dependent on the DPI minus 1. DPI minus 1 means all the result calculated before at index I minus 1. So when it comes to index I, for example, this is index I, this is the index I minus 1. So for this I, we just need to check all the bitwise OR operations inside the DPI minus 1. Inside the DPI minus 1, it can be a set. So we're gonna check all the values with this set. Maybe you think this is also O(n) square, but actually it is not. This is just because this is just n log n time. So why it is n log n? Because for each of the numbers for the bitwise calculation, it can be 32 result. So for example, this is the array, and inside of this array, for example, this number will use bitwise OR with all the numbers before. So how many possible results? There can be only 32. For example, from the beginning, all the result can be, all the result is 0. Now we are going to use bitwise OR. For the bitwise OR, because it is bitwise OR, the 0 can only become 1, and 1 can never become 0 again. So it means for one operation, some of numbers maybe can become ones. And for the next number, for example, this number, so some of the numbers can become ones, and similarly for the next number, and some of the number can become ones. But once the number from 0 becomes 1, it can never become 0 again. It means for each of the bit positions, there's only one possible result. So in total, actually, there can only be 32 possible results. Because this is the property of the bitwise OR operation inside the array. So this means 30 times 2 times n is the final time complexity. Actually, it is similar like the brute force, but the brute force can use to solve this problem. Actually, this is also a bit dp. So the idea is bit dp, but the calculation is brute force. We just need to prepare two sets. One set for the calculation, another set is for store the result. We just needed to return this final result. Let me go to the code editor to finish the coding. So we need to prepare a two set. Result and answer is going to be empty set. Now we are going to loop through the numbers inside the array. So for each of the answers, it is a set bitwise OR the current number. And for this set, because we prepared all the possible result, all the dpi-1 result inside this answer, so we can just use a bitwise OR operation. So n with a bitwise OR, let's say the number can be inside the set, the number, let's say x. So for x in the answers. So this is when it comes to DPI, the answer is DPI. So but the final result is the sum of all the answers. Actually it's the sum of all the answers. So here we can still use a bitwise OR with the result. Here we will not bitwise OR. Here is it's not bitwise OR. It is the set OR operation. It is the set union operation. So it is the set union operation. We just needed to use this set with the current answer. So finally, we just need to return this result. I didn't say. So for this operation, because it's a set operation, so this is the set union operation. But in the whiteboard, when we need also to use the set, it is also the set operation. But for analyzing the time complexity, this is the bitwise. For this 32 possible result. Now let me run it to check if it works. So this means we need to use a set. It's not integer. Now let's try again. Because we need to return the length of the set. So we need to return the length, not the set itself. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and it's pretty fast. Thank you for watching. See you next time.